Great. Well, thank you very much. And I'll introduce myself in a little bit of a second, but welcome to this discussion. I'm a little flustered. I was actually, for the last hour, I've been at a workshop on angel investing. I'm also an angel investor, and we were talking with some people here in Arizona that are interested in getting into angel investing. So it's a startup night. So I'm here today now switching gears from investing to talk about how to use something I've spent my whole career doing, simulation, to secure success in your startup. So it's really about how to get to market faster with a better product, driving your design with simulation. So a little bit of an introduction, a little bit about ANSYS background. Now I'm not going to go into detail on some of these slides. They'll be available to you through the recording as well as other methods through Hardware Massive. But ANSYS is the market leader. They're 3 times bigger than their closest competitor. These are things that are important if you're going to make an investment in a software tool, right? They have a considerable financial commitment to deliver value, 75 locations, over 2,700 employees in 40 countries. We're going to talk a lot about their startup program. There's over 325 companies in the startup program right now, and it's growing every day. And the only thing they do at ANSYS is simulation, and that's really important. They're also independent, they're financially stable, and they're CAD agnostic, so they're not really tied to any geometry engine. They can do whatever they want. And they're a truly multi and multiple physics product, and we'll talk about why that's important. And I've listed their different, you may just take a look at the list over here and see some of their products. You may have heard of these in college, you may have a colleague that mentioned them. These are the market leaders, technical leaders as well. About my company, PADT, we're a products and services company where we help people who make physical products do the development. So we sell the tools they need, and we also do consulting for them. 3 areas that we focus on are simulation, which we're going to talk about today. We have a whole team that does nothing but product development. They just work with companies to design, test, and build products from scratch or anywhere in that process. And then also we've been doing 3D printing since we started the company 24 years ago. So we've been a leader in additive manufacturing and continue to do so. We're actually about 80 employees now, based here in Tempe, Arizona, but we have sales and support offices in Colorado, New Mexico, Southern California, and Utah. We're an elite ANSYS channel partner and have been working with ANSYS as a sales partner for over 20 years. And as I mentioned, we're a very active investor / mentor in the startup community here in Arizona. The group we work through is called Arizona Technology Investors. That's the event I'm at today. And besides ANSYS, we sell Stratasys 3D printers, desktop metal, and our own computers. So we do a lot. Hardest part about marketing our company is we do too much. Myself, I'm one of the co-founders and a principal at the company. And I share ownership with 2 other partners. Shout out to those of you in Berkeley. I got my degree there probably before some of you were born. Unfortunately, a lot of you. In 1996 in mechanical engineering. So I've been doing this for a while. Started programming in high school 37 years ago. Started using CAD when I was at Cal 33 years ago, and I started using simulation my first day after I graduated. Actually, my first day of my working job here in Arizona 31 years ago. So what I do at the company is I'm responsible for the consulting team. So we do simulation, medical devices, and product development as a service for folks. I also head up marketing, IT, HR, administration, facilities. Of course, I have people that do all that stuff that report to me. I do a lot of speaking and writing, frequent blogger. We just started our first podcast. I do a lot of articles, and I speak on things from startups to simulation to running a small business. Like I said, I'm an angel investor. I'm on the screening committee here, and I do technical due diligence. And if it's hardware, I usually am the guy that gets stuck with it because everybody else on the screening committee is a software guy. And then I judge for grants and competitions, and I do quite a bit of mentoring. So very involved in that community. So that's enough about me. Let's talk about why we're here today, which is the next slide. It's like I prepared that. So why are we here today? I'm gonna put a stake in the ground. I don't know how many of you are from the U.S. that are not from the U.S. that don't know that phrase, but it's basically saying I'm gonna make a very strong statement, and I'm gonna stand by it, that the proper use of simulation can make the difference between the success and the failure of your product startup. If you're not using simulation, you're increasing your chances of failure. If you are, you're increasing your chances of success. And I'll talk about what simulation is and why I think this statement is true as we go through this. And then we'll talk about what to do next at the end. So let's talk about a startup. Those of you that are involved in startups know these things, right? This is the moving parts in a startup. You got to define a problem. You got to find a solution. You got to go out and raise money. You got to plan what you're going to do, design your product, raise more money, do testing, do some marketing, get sales up and running, raise more money, go into manufacturing, set up your distribution, get your support going, and then when your product's successful and out there in the market, you got to keep making improvements to it, right? This is the kind of the life cycle of a startup that's doing hardware. I feel like simulation can help in these key parts, and we'll talk about all of them, but it can help define the problem, find the solution to the problem. Of course, it's used to drive the design. It can replace testing or make testing less expensive. It helps on the marketing side, and we'll talk about not necessarily in the obvious ways. Manufacturing is a key area where simulation plays a significant role. And then once your product's out in the field, when you start having problems with it, or you need to fix something or make an improvement, simulation plays a huge role in that as well. So let's kind of start at what we're talking about here. What we're doing is we're using computer models to drive design. And so I found unfortunately this is not the oldest telephone, but it was a good picture. But let's think about how we went from this wood box that basically is an analog device that had some electromagnets in it, a speaker, which is electromagnet, a microphone, which is electromagnet, and you basically run current through it, and you see how vibrations either change things or ring bells and things like that, right? Pretty basic device. To our smartphone, which is an incredibly complicated device. And the phone calling part is one of the simplest parts of it all, right? So how we got from that box to that cell phone, a lot of it was simulation. It's really, really devices are really complicated. I mean, you can make that wood box better with simulation, but it doesn't add you a lot. The complexity is what's driving it. So it's a standard practice in established companies. If any of you come from an aerospace or a large electronics company on the mechanical side, you know that they use probably ANSYS heavily in those companies. It's required. It is how you develop products. Because we want to study, what we're doing with simulation is we're studying how our product behaves on the computer. And there's huge benefits to that. It's a lower cost than physical testing. It's faster. It gives you understanding of your product, and it allows you to make your product improve better. In fact, earlier today I was at a seminar where customers were presenting about how they use ANSYS products, and one of them was from NXP. They make the power transistors in cell phones. They're the primary supplier of that. And he talked about how they're solving the heat, the things, there's such a small space, they get too hot, and how they use ANSYS to manage that heat problem and improve the performance and use less battery power in a cell phone. So more detail on what simulation is. I like to start with the definitions. So the first one is useless. Simulation is the act of simulating. Okay, we know that. The second one we don't really want to talk about. It's a sham object, a counterfeit. We're not talking about that. We're talking about 3A and B. It's the imitative representation of the functioning of one system or process by means of the functioning of another. And they actually, in the dictionary, use computer simulation of an industrial process as an example. It's also the examination of a problem, often not subject to direct experimentation, by means of simulation, right? So you instead of actually looking and measuring on the physical thing, you're using some sort of a copy of it that you can look at. And that's what we're really talking about. In product development for engineering, we're basically writing mathematical systems to represent the behavior of that physical system. And we're using equations to predict that behavior. So we write these equations, and then we solve them using a computer. So that's what's going on under the hood. We got to somehow figure out what these equations look like, throw them into a computer, and solve them. When we're doing physical product development, we use a process of discretizing the complex systems. You know, some kinds of simulation we can write an equation for. But when we're talking about complex hardware, we generally can't write an equation for the whole thing. So what we do is we break it up into chunks that we can. So we break it into these chunks. We write these equations for the chunks, which are a little bit simpler. We put them together and we solve them. Terms you'll hear are finite element analysis, finite difference, boundary element, finite volume. These are all ways of breaking a complex problem into easily definable chunks and then putting them together, finite elements, putting them together and solving them as usually a large matrix. So it's a software tool. What is it practically? So that's the math, that's the background. It's a software tool. It's a standard commercial tool out there. It's very well established. This is not new. I've been doing it for 30 years. It was around before me. It's robust. It's supported. It's efficient. It fits well into the whole product development cycle with the up and downstream software tools, your CAD, your manufacturing, your product data management. All these things work with simulation. And you'll find when you get into the tools, they'll have a look and feel that you're probably familiar with from using some of those more widely used engineering tools like, say, CAD tools. Simulation for mechanical engineers is taught in engineering school. It's often ANSYS, and so people that are graduating now know something about simulation if they have a mechanical engineering degree. And it runs on standard computer hardware. You don't have to go out and spend $5 million on a computer, but the more horsepower you have, the faster it is and the better the experience. But it's not crazy. A big change from when I started is that it's very easy to use. It's very easy to learn, and more recently the big change is that you can actually remember how to use it. Because what we're seeing more and more is you'll use it for 2 weeks, you'll go off and do testing, or you'll go off and do, especially for a startup, you'll go off and raise money probably. When you come back 6 months later, you still remember how to use it. They've really worked on the workflow so that it's intuitive and easy to remember. These tools are not stagnant. They're constantly evolving and improving. And the other thing is that it's not just, you may come to this discussion, you may be an electromagnetics guy, or your device may be driven by thermals or fluid flow. We measure all that. We interact with all those physics and the interaction between those physics. So you're not really limited on the physical behavior that you can represent. So if you are new to simulation, if this is something that you're not familiar with, I always like to tell people that it replaces testing. We actually use the term virtual testing often. So if you're looking to do a test to get information, like you're looking at your product development process and you're going, okay, at this point we're going to build a prototype and we're going to take it out in the field and we're going to measure, let's say it's got an antenna in it, how strong the signal is from the antenna. You can do that instead of testing it. You can do it with simulation. It's faster, cheaper. You can actually take that antenna example. You can actually see what's blocking the signal if it's being blocked, and it gives you more insight. And there's a lot of other smaller things. For me, this Honda model over on the right was a breakthrough for us in the simulation world, and it was back in 2014. It's one of the most complicated simulations you can do is basically crashing a car. The only thing more difficult is crashing an airplane, which people do now. A lot of parts, a lot of different material properties, a lot of different joints and connections and things. It's kind of hard to get right. It's not that hard to do anymore. This was done by Honda using a code called LS-DYNA, which is sold through ANSYS as well. And it's almost identical results from the simulation. Multi-million-dollar test, maybe a $50,000 simulation. Big difference. Definitely faster as well. You have to build the car to do this test. You don't have to build the car to do the virtual test. So the application is broad. We're writing mathematical models, so it's full multiphysics. You may think about stress, temperature, and fluid flow because those are the big ones that we do the most of, but we can do low and high frequency electromagnetics. Chemical reactions are something that we really have a good handle on now. This is an area that's really growing quickly, mostly funded by the oil and gas as well as the pharmaceutical industry. They love it. We can do impacts, cracking, shattering, metal forming. The control systems, you may be doing an electromechanical device that has a control software. That can all be modeled and simulated, as can the software and the user interface. ANSYS has some tools in that space, as do other companies, where you can do virtual testing of your software and your user interface and how it interacts with your hardware. So you need to think about the system all the way down to the component when you think about simulation. It's not just the component. And think physical behavior. If it's something that you can measure in a test, we can probably model it. It's pretty easy to do. So that's what simulation is. Let's talk about why it's important for a startup, because what we're doing in a startup that's making hardware is we're designing a product. We're doing product development, and we want to drive that product development as quickly and efficiently as possible. And the term driving is intentional. You know, in the industry, we went back and forth, and what do we really want to call this? And we ended up with driving because we're not steering or informing, but we're actually pushing it forward. It's a motive force. It's not just kind of giving us answers to things. It's pushing things. And think about it. This is the first car. It's a Mercedes car. It was a very basic device. It's kind of cool if you've ever seen it. It's got a giant flywheel. It's very basic. If you have a mechanical engineering degree, you should be able to design and build this. This is Lucid, which is a competitor to Tesla. I think it's a more sophisticated car than Tesla. They use ANSYS more, so I like them. But it's a really, really cool electric vehicle that's very impressive. So think about how far we've gone from this very basic device to this vehicle. And one of the things we like about Lucid is it's a startup that used ANSYS to drive the design of this vehicle. Every aspect of this vehicle was driven with simulation. So what is design? Step one is you make a list of what you want your product to do. Then in step two, the hard part is you come up with a configuration that does what I want. And then in step three, you got to make sure it does. You don't want to go to market without knowing that it actually does what you want. So what does simulation do? For that first step, it really tells you what can you do. It answers that question. You know, you have a list of features you want, but are they actually doable? You can answer that with simulation. As you're doing your design, you can look at what works well and what doesn't, and then at the end, you can see, does it really do what I want using simulation rather than test? So if you remember back to that list of the steps in a startup, the kind of the gears that turn in a startup, the ones that are driven by that the simulation can really help. Let's talk about, you know, you start off by saying, well, what's my problem? Well, you may know it from an external standpoint, but what's really going on? You really want to understand deeply what you're trying to solve. Like maybe your competitor has a device that's some sort of a thermal device, and it freezes sometimes. So if you want to, the problem is that everything on the market freezes, and you don't want it to freeze. You can use simulation to understand that. And then when you come to your solution, you have an idea, but do you know it's going to work? Well, you can use simulation to see whether your solution is viable. Then you get into the bulk of what you're doing, which is design. So this is no different than standard product development. And what the aerospace guys and the electronics guys and the medical device people use simulation for. It's the same with a startup. The difference is, in the startup, you don't have any previous information. You probably have a blank sheet of paper. So it's even more important to use design. Then when you get to testing, it's also the same as for standard product development. But you have no previous information to start with, again. So you don't have anything to base it off of. So simulation is really useful to give you that core information before you have anything. Now, in marketing, we often think about using simulation to make pretty pictures, you know, and see how those pretty pictures, how they work. But what we really want to do is know what our differentiators are, right? When you really sit down and think about marketing in a startup, nobody really wants to see a pretty picture. They want to know, how is your product different and better than the other things out of there? And simulation can prove out those differentiators. It can tell you that your product really is better in this area. It is a 30% improvement in blah, blah, blah. So that's the way to think about simulation for marketing, is to answer those questions of what your key differentiators are. For a startup, manufacturing is probably a complete unknown. You're doing something totally new and different. It's a new piece of hardware put together in a new and different way. And so you can simulate that process and make sure that you can avoid problems in the manufacturing, because that's the most expensive place to make a change. And then once your product's out there, you know, you have no data. Your first field failure, and you will have field failures. You don't have a lot of data to figure out what's going on. You can use simulation to understand why it failed and fix it. And then once you're really going, you're going to want to improve your product, right? And so it's the same for standard product development. You're going to want to look at what you have, understand it with simulation, and then because you have no previous data, you need to just kind of really dig into it and understand where you can make improvements. So it really plays a role. Most people just think of it in the design phase, but through the entire product development process, it's really important. Now, we always talk about how it saves money. And that's because when you make a change to your product late in the process, it's really expensive. You've invested in tooling, you've invested in all that design time, you've probably built prototypes, you may even have your marketing stuff going. Now you got to make a change, and you have to modify your prototype, and then the best case is you just modify your prototype and then you change your design documents. That's nice. But usually you have to go and redo your tooling, and there's other problems that it usually causes. You fix one thing and it causes a problem someplace else. It's really expensive. So study after study has shown, and it's kind of intuitive, that the earlier a problem is found and changed, the better it is. And simulation enables this because I don't have to have any hardware or a lab. Before I make anything, I can design it on the computer and test it on the computer. It's also faster, so you can get it done earlier, and it doesn't really delay your process. So we talk a lot about understanding your product. When you do a test, you may get one or two numbers, and whether it worked or didn't work. With simulation, you can get in there and dig deep, and testing or guessing gives you. The other thing is it only tells you, if you're doing a test, it only tells you what you measured. But what if you look at what you measured and go, I wonder what's going on over to the left of that point I measured at? Simulation tells you all that. It lets you dig inside and understand it. And this was driven home today at the event I was at earlier today, where a VP of engineering of a large company that makes the machines, one of the machines that makes semiconductors, epitaxy machines, talked about how with tests they never really understood how their deposition really happened and how they could get an even deposition of the materials they're depositing on a silicon wafer. With simulation, they were able to get in there and understand that deeply, and then understand, if I made a change, how it affects things. So the sensitivity is really important. You need to know, is feature A or feature B more important for performance, because you got to make decisions on which one you're going to invest in, and also what geometry features impact the characteristics of your design the most. So this really helps you make those design decisions. Now, all of you who are thinking about a startup or involved in a startup should know about minimum viable products, right? It's the idea that you come out with a product that only has the features that are needed, the minimum number of features needed for the product to launch. But what are those features? You can guess, but simulation will help you make an intelligent decision early on in your design process. So you're not out there designing 30 features so you can test all 30 features and then figure out which 3 you're going to go with. You make the decision early on. It tells you what the impact of a feature is on performance, how difficult it may be to implement a feature, and also the interaction of one feature and another. So you can use simulation to determine what your minimum viable products are, and meet those minimum performance goals with that minimum feature set. So it's really important to use simulation to come up with that minimum viable product. So hopefully I've sold you on the idea of simulation. It's definitely the industry standard for established companies. It should be the industry standard in a startup. So, go out and buy a tool. That's just the first step, right? So in order to be successful, you have to have, number one, the right tool. If you've got a free tool, maybe you downloaded something off the internet or it's CAD-based, it's not going to do what you need. It's going to be a basic tool. It's free for a reason. The other thing is it needs to grow with you. You may say, well, I only need this right now. But as you get into the product development, you're going to need more. And as you go, you get your Series A funding, and now you're in production, and you're spending a lot of money, and your product's getting really complicated. The product needs to grow with you. If you go with a low cost or free product, it ain't going to grow. And the other thing is you shouldn't have a tool that limits you. That's the whole point, right? You're doing new and exciting things. You don't want stuff that limits you. The next thing is a user. You need to have the right user. A guy on the team that says, oh, I used ANSYS in college, that's a good start, but you probably need more than that. If that's what you have, that's great. But pay for experience. Maybe you can hire somebody part-time or get somebody on your team that's that's got experience with simulation. Or if you can't afford that, get some mentoring from somebody that can help that person that used it in college. Running the software is just one aspect. The key thing that this experience brings to you is not which buttons to push to get the answer. It's understanding how to apply simulation effectively. And that's where the mentoring can really help. You may have somebody that can actually run the tool and learn it, and because they're very easy to learn and use, but bring that expert in to help you how you use it. Also, you need a good support provider. When you're buying this software, it's an investment, and you don't have time to figure stuff out by yourself. You need to be able to pick up the phone and talk to somebody and say, I'm trying to solve this problem, how do I do it? A lot of tools out there. The only support you're going to get is an online forum, if you're lucky, or you may get an 800 number that may call you back in 4 or 5 days. You want somebody that's got a series of experienced engineers or a set of experienced engineers that are going to answer the phone when you call or answer your email when you send it and understand how you're trying to use the product, not just how to install it. You also need an implementation plan, right? As a good engineer, you should always have an implementation plan for whatever you're doing, whether you're installing a piece of equipment or a new piece of software. And part of that is looking at how you're going to develop your product, what your product development process is, and where simulation fits into that process. Identifying that up front is really important. And you also need enough funding. The cost of software is step one, but you need to be able to have a decent computer to run it on. You need the people, maybe some mentoring, some training, and you need money to implement it. You're not going to just be up and running right out of the box. You need some time, some overhead cost to get your head around it and know how to use it, even if you're an experienced user, how to apply it to your particular problem. So that's a very quick look at why I think simulation is such a good tool. So let's for startups and how it drives your success. Let's talk about some success stories. So it's good and dandy to talk about theory and what I think is going to happen. Let's talk about what really happens out there in the real world. And I'm going to talk about the ones that we've worked with. There's tons out there, and if you go to the ANSYS website, you'll see more. So one of my favorites is Velox Motorsport. They make aftermarket automotive components, and they were basically literally building these things in their garage. Well, not necessarily garage, but they're in their suite, their office suite. They had a roll-up door. They're building things back there. They would bolt it onto their car. And they would tape little pieces of string onto the car, and then they would drive behind it in another car and take pictures of it with a video camera while they drove around to see what kind of turbulence and things, and kind of try and get some sort of a measure. Maybe they put on a flatbed truck or something. They couldn't afford to build models and pay for a wind tunnel, so they were doing it that way. So with ANSYS CFD, they were able to optimize their aerodynamic performance, avoid that cost of multiple models and paying for wind tunnels. And that on-car testing they were doing, they could kind of tell what was going on, but it's really kind of hard to measure it. So ANSYS CFD was great for them. They were able to see what was going on and do it very inexpensively. And they liked it so much that they got ANSYS Structural as well. And so they took the loads from, this is multi-physics, right? So they get these pressures from the turbulence and suction on the back of the car, and they want to make sure that the aftermarket bumper is rigid enough to where it doesn't flex or come off. So they were able to do that with the mechanical product. So the quote there is that ANSYS has proven to be a superior tool than what they were using. They're basically using a free plug-in to their CAD package. So it sped up their capability and improved their accuracy. And again, back to the idea, you don't have to work with PADT, but you need somebody like PADT that was instrumental in helping them understand how to use this technology. So they feel like without PADT and ANSYS, they wouldn't be where they are today as a company. And they're doing quite well. Their products are clearly differentiated in the market. They're better performance, better durability. One of my favorites, they just had a major milestone this last week where they actually launched their first high-altitude stratospheric balloon. What they're basically doing is instead of making satellites, they're making stratolites, which are platforms that sit in the stratosphere and can be used to send signals as observation for cameras, the same things you use satellites for, but up in the stratosphere using a high-altitude balloon. It's a disruptive technology for commercial space because you don't need a rocket, right? It's very inexpensive. But they wanted to be, all the applications are going to be totally different. So they wanted to create a robust and durable stratolite flight platform. They wanted this thing down here that they could put whatever they needed to on it and it could land because they had this broad set of missions and applications. So they used ANSYS FEA for structural and dynamic analysis, as well as optimizing the shape of the thing. So you can see some of the simulations they did here. So they've been working with us for years. They are a startup, but they came out of another company that was a customer of ours for a very long time. They've been a great partner for us. We've really enjoyed it. So we really help them ensure that their design withstands the rigors of launch into and flying through the stratosphere and coming back, which is the hard part, from the stratosphere. So we're really excited. They actually did a bunch of tests over the last year or so to confirm what was going on, and they did their first full flight last week. And everything, one of the things I didn't really talk about is we use simulation not to avoid testing. You still have to do physical testing, but testing becomes verification instead of a fact-finding mission. So they verified that a simulation was done correctly. Some others, because we're limited on time. Nebia's, I need to try and find a way to buy one of these things. It's a low-water, high-performance shower. So what they basically wanted to do is get away from the traditional shower and go with a mist. But they wanted the mist to hold the heat. They didn't want it to cool off as it comes down. And so it's a very complicated fluid dynamics problem. And they were able to replace expensive build and bust testing. Can you imagine these different nozzles, building them, testing them, building them, testing them? It was very expensive. They got a 70% water savings, and they increased the amount of water contacting the skin by 10%, because that's actually their driver, is how much warm water is touching the skin is kind of the performance they're looking for. Mohi Labs is a really interesting one. They're trying to replace propellers and all these quadcopters you see out there with basically an impeller, so a bladeless drone. So you can get away from those spinning propellers. Very complicated aerodynamics in that device, but it has to be light as well. So simulation was great to drive the design. Understanding the complex physics, solving their weight problems, and they were able to make changes and understand what was really going on inside their device when they made those changes. So it's a great success story as well. NeoGraft, going over to the medical side. It's a scaffold for heart bypass of veins. You can kind of see it over here. They take the vein and they kind of put it on the outside of the heart. And it needs to sit inside a scaffolding of some kind until it's totally integrated into the heart. And this is one where, how are you going to test that? It's really, really hard to test. And when you want to make a change, you can work with cadavers, so that's not the same thing. You can work with animal analogs, a pig maybe, but that's really expensive and difficult and cruel. So by using simulation, they were able to really optimize their design very quickly in a way that was not possible with tests. And these are their quotes. And then Bragi is another device I really want to see if I can get a copy to purchase. It's basically Siri or Alexa in your ear. And all that stuff that's maybe in your cell phone or in the Alexa thing, fitting inside an earpiece. Very sophisticated, antennas, power, everything you need in a small package. So they had some significant hardware design issues to solve. And they did it with simulation. It allowed them to do variational studies to vary the parameters that defined their geometry and their packaging in order to fit everything into this very small package. So good success there. These are just some of the examples that we know about. And there's, like I said, there's over 300 companies out there using it. So lots of good stuff going on. So we've talked about, how I think simulation is really important to make your company successful, what it is, why it's beneficial, some examples. Let's talk about what you're going to do next in order to get simulation to be part of your product development process. So some good first steps are to really understand your product's performance goals. Start there. What do you really want to achieve? You should probably already have this, and if you don't, it's a really good exercise. What do you really want your product to do from a performance standpoint? Once you've got that list, go through it and say, where can I use simulation to help me achieve this goal? You may have a requirement that it runs in the Antarctic as well as in Phoenix in the summer. So you've got very hot and very cold. Testing for that's very expensive. Simulation can help you achieve that goal. Also, map out, you should be doing a failure analysis on your product, right? You should be going back and saying, these are the different ways, the different modes that it can fail with. Once you've identified those, figure out where you can use simulation to predict it and fix those modes. Make them less probable, if not impossible. Also, as part of your product development process, you should be planning out your testing. So what kind of testing are you going to do as part of your product development process? Now, once you've figured out these physical tests you're going to do, step back, take a look at them and say, where can I replace a physical test with simulation? Or where can I use simulation to make sure that I'm probably going to pass that test? So it just becomes a verification test, saving time and money. Once you've done all that, so now you basically, those first three steps are saying, here's where, from a performance standpoint, a failure standpoint, and a testing standpoint, where simulation can benefit me. We know it's going to benefit you in design, so we don't have to do that. Identify a tool, a user, and a support provider based on what you need, what your niche needs are. Figure out an implementation plan. How are you going to roll this out and use it in your company? And like any good engineer, you're not only just going to execute on that plan, you're going to continuously improve the plan and make it better every time you take a look at it. So this has been very effective with many companies. I really recommend that you look at the ANSYS startup program. There's no other tool set that's as full-featured or capable as the ANSYS tool set. It is full physics and true multi-physics. It's one of the other reasons why we recommend it is that it's used more than any other tool out there. So you can find experts. If you're from a family of engineers, you may know somebody in your family or your friend group that knows ANSYS and can be that mentor to help you use it. Or if you need to hire somebody, it's going to be easier to find somebody that knows ANSYS. One of the questions you're probably all waiting to ask is, well, how much does it cost? It's very affordable, and you're not getting a dumbed-down version. You're not getting a free version. You're not getting a student version or a startup version. You're getting the full suite of ANSYS products at a price that you can afford. And it's hard to define what that is, but when you're ready to look at bringing ANSYS on board, you'll work with your ANSYS salesperson, and whether that's a channel partner like PADT or a direct salesperson, and they will help you figure out what you can afford. If you're an early stage company, it's going to be really cheap. If you've got a lot of funding, you're on your Series C round or something like that, then you're going to pay more. So it's what you can afford. I think that's very smart of ANSYS. Instead of coming out with like a super cheap, dumbed-down product, this is the full product. We're going to look at you and make an investment in your company and decide what can you afford, what's the value for you, and we're going to go ahead and charge what you can afford to pay. It's an annual lease, so every year you re-up that you need it until you are no longer a startup. As you grow, the software can grow. You can add more seats, you can add more physics, you can add more capability. You're not stuck with transitioning from a simulation tool to another one. It's also supported by world-class engineers. Companies like PADT, the ANSYS Direct technical support team is outstanding. When you call them up or send them an email, you're not going to get a new grad that has a script. It's going to ask you 5 questions about why your problem's not running. You're going to get an engineer that's used ANSYS in industry, whether it's direct or through a support provider like PADT. And we have one of the things is this is a pretty advanced software, so you may be going, oh my gosh, our users are really basic. We have tools for every level of user, but you don't have to give up functionality. When you use our AIM product, which is our kind of design product, that's a kind of a set workflow, it's got a nice user interface, it leads you through the process. underneath it is the same solver as our high-end tool. It just presents it to you in an easy-to-use way, removing all the bells and whistles from the user interface, but they're still there. So if you need them, you can get to them, and your support provider can help you. So we have something from the novice to you did your PhD thesis on whatever it is your product is based on. We can model it. We have the full capability of physics there. So I really recommend you checking out the ANSYS Startup Program, which is my last slide. So if you want to learn more, contact myself. I'll send a little text message when I'm done talking with my contact info. Or just the best thing you can do is go to www.ansys.com/startup. They'll have videos and examples and other success stories there, lists of other companies that have used it maybe in your industry or your area. And there'll be a form in there. Once you fill out that form, somebody from the channel or from ANSYS Direct will contact you and figure out what your needs are and what the right package and pricing is for you. So that's it. That's all I have to share today. So I guess we'll just open it up to some questions.
Hey, Eric, this is Matt here. So thanks so much for the presentation. I'm going to put it in the Q&A mode here, and everyone listening right now, you'll get a prompt on your screen allowing you to ask a question, and then I will address those as you guys fill them in. So hold tight here. All right. Eric, can you hear me?
I can hear you just fine, yeah.
Perfect. All right. So everyone should have gotten a question here. And okay, great. So got one question coming here from Mark. I'm going to give him the floor here.
Hey there. Great presentation. Thank you.
Thank you.
I was wondering, what about modeling extreme heat events up to explosions? For instance, the thing I'm thinking about modeling is a LiPo battery charging inside of an enclosure that explodes and ruptures.
So that's not on purpose, right? That's a failure mode?
Yeah, basically, because I'm probably going to have to do destructive testing. It's very expensive to test something to all that way. So I'm wondering so that's something that makes me think that simulation might be an interesting choice.
Yep. Yeah, definitely something to do. One of our fastest growing areas of simulation is battery simulation.
Mm-hmm.
So most of the battery guys are looking at using ANSYS to not only design the product, but also do these failure modes. So a chemical reaction that drives your explosion, we can characterize that as a heat generation event, as well as a pressure event. And apply that as a boundary condition. And see how you're. I'm going to assume you're multi-layered stack, and how that kind of explodes, and how your containment vessel distorts.
Mm-hmm.
We all know about the galaxy experience.
Yes.
I don't know if they used ANSYS or didn't use ANSYS, but I've worked with aerospace batteries where we've done that kind of simulation.
Okay. One other question, real quick, if I may.
Mm-hmm.
What's the workflow like going? I'm actually working in Fusion 360, and I assume I would export a SAT or a step file or something like that into ANSYS. What's the workflow like as far as re-importing? So I assume I'm going to bring stuff in ANSYS. There's going to be, as I'm doing simulation, I'm going to be attaching metadata to the model. When I bring another revision in, how much rework is?
Great question. We didn't really get into how the product works. So Fusion 360 is Autodesk, right?
Yep.
Yeah. So we're bidirectionally associative. So you don't import the SAT, you attach your model. We read the geometry directly from their geometry engine. We bring it over, we mesh it. If you change a parameter in ANSYS, it actually goes back, changes the parameter in Autodesk, and then comes back and updates the model in ANSYS. Now, it's not 100%. You always run into situations where your topology changes or significant difference. But 90% of the time it works. So you don't have to deal with that. You set up your model once and make your changes.
Okay, great. Thanks a lot.
Mm-hmm. Mm-hmm. Thank you, Mark. Thank you. All right. Anybody else here online have a question for Eric while we got him here?
Yep.
All right. Anybody else here online have a question for Eric while we got him here? you can type it in the chat box or post it in the Q&A portal. Eric, it looks like no one else has any questions here.
I'm sending my email address right now. Feel free to contact me there. And my website as well, /blog, is where our ANSYS blog is.
Perfect. Thank you so much for sharing that. And also the presentation, again, is recorded and will be republished on the Hardware Massive Resource Center. Look for that in the coming couple weeks here, and you will get an announcement in your email box about that. So other than that, Eric, really appreciate you coming on here and sharing some insight into your ANSYS software. And if there's anything else you want to say?
The only thing I would add is good luck, and don't hesitate to use the right tools to get your product to market faster. It's a great experience, and hopefully you guys will enjoy the ride as much as we have through the years.
Perfect. Thank you so much, Eric.
Thank you.
Have a good night, everyone, and we will see you at the next webinar. And yeah, have a great week ahead.